I know the coffee break is great, and part of the event is the networking and meeting people from all over, but we do ask you to come back in and take your seats for the next part of our agenda, which will be our sponsor testimonial with FutureGrid and one of our members, Sidalis Tikls from the Latvian E.DSO. So please come and take your seats. We'll be just starting in just a minute. So good morning again. We ask those who are outside to please come in, but I think we have a good-sized crowd here already now. And so we're going to have a presentation by one of our sponsors, FutureGrid, along with our member, Sidalis Tikls, which is the DSO for Latvia. I have been to the office of Sidalis Tikls just in July, and they're doing a lot of innovative things, so I think it's really interesting to see how a company and one of our members work together. So with that, I'd like to introduce to the stage Alberto Mendes Rebollo, who is the CEO and co-founder of FutureGrid, and Petres Lucis, innovation lead at Sidalis Tikls. I leave it to you.
All right. Thank you, everyone. Let's find the right slides so we can start. Perfect. Thank you. So yeah, pleasure to be here and talk today about our common project with FutureGrid. Just about Sidalis Tikls. We are the largest DSO in Latvia, operating low and medium voltage. We have around 1.1 million customers and 100% smart meter deployment and around 1,600 employees. And when it comes to the topic of flexibility, we were very grateful to be part of the EU Horizon Project OneNet. There were many TSOs and DSOs from Europe. That was really, well, as a DSO, our first exposure to energy markets, really learning from TSOs what capacity products and energy products really mean. And also trying to outline what is the roadmap of flexibility for our network. And given that in the 3 Baltic states, Lithuania, Estonia, and Latvia, we have also retailers operating across, we are closely collaborating with our neighbors to try to reduce any market barriers to the retailers and aggregators as much as possible. And now we have embarked on a 2-year project with FutureGrid, which is called ST Flex, and where we really now are looking forward and already having the technical requirements, the development and demonstration, both for flexible connection agreements and flexibility markets. The topic is still the same, trying to figure out when and where we need to build bigger lines and bigger transformers versus trying to flatten that load curve. But what is special or typical for Latvia, we have much longer medium and low voltage lines, meaning that we more often experience voltage constraints rather than transformer line overloading. And that obviously complicates a bit the implementation process. In terms of use cases, the most common one is that when we have a new customer, we don't have free hosting capacity. And we are then entering a bilateral agreement with the customer. And here we have FlexiGrid that provides a DERM solution where we can actually then interact then with the end user assets and then control them during those peak moments. And our focus with FlexiGrid is on a low voltage network and on a demand side customers. And then more complex scenarios where we have a new customer that requires firm capacity, or we see increasing consumption from the existing customers that most of the time would reflect as changing the load pattern and creating new peaks. Then this is where we internally decided to, first of all, build our own flexibility register and a flexibility procurement platform. There are many great solutions out there, but just the reason to go in-house was just due to flexibility on how the solution looked like and cost efficiency. And here, FlexiGrid helps us with the DERM solution in terms of communicating with those retailers and aggregators who are then responsible for actually activating that flexibility. And just last one from my side, in terms of the exchange principles. So at the core, we have this E.DSO Flex, the procurement platform. We spend quite a bit of time also on trying to understand what is the flexibility baseline and validation methodology, when can we rely on 15-minute smart meter date, and when we need dedicated measurement devices. That took quite some time. And we also have integration with our national data hub, STEP, and obviously all the required integrations with aggregators and retailers to both procure it, but then also to give it for FlexiGrid for the activation of this flexibility or for the direct control of the end user assets. I'll hand over to Alberto.
Thank you. And it's a pleasure to partner with E.DSO for this project. My name is Alberto Mendez, co-founder and CEO at FlexiGrid. I'm electrical engineer. Work all my professional life in energy transition, about half of that in renewables. I was a regional CEO at Siemens Gamesa, the wind manufacturer, 20 years ago, when wind was a startup. I worked 13 years at Vattenfall, the Swedish utility, as head of wind power, and later on as chief procurement officer for the whole group. And I decided to leave everything to focus on what I think is the largest challenge of the entire energy transition, which is the grid. And so, about 5 years ago, along my co-founder and CTO, Pablo Arbolella, we decided to leave everything and to focus on this new challenge. And respect for the DSOs today here, because I think you're confronted with the largest technological, regulatory, and stability, resilience, competitiveness challenge in 100 years. I think we built Grid 1.0, our ancestors, no? Edison and Westinghouse and Nikola Tesla, for a system with large, centralized, dispatchable power plants, with very predictable power flows from the large power plants to the cities, to the households, where the distribution grid was mostly passive. And I think energy transition is one by one exactly the opposite, right? We have hundreds of millions of distributed, intermittent DERs. We have bidirectional is a ultra simplification. You have extremely complex and, of course, bidirectional power flows. A simple street or a simple feeder is now a Jumanji. You have power generation, you have storage, you have electrification at the scale. It's becoming immensely more complex than transmission, that's clear. And transmission used to be the most sophisticated thing. We believe, our thesis is that the DSO of the future will have to have 3 superpowers. Real-time visibility in each and every node on your network. The problem is you have millions and sometimes tens of millions of nodes. The second is real-time analytics, like a TSO, the ability to compute the state estimation and power flows, voltage, currents in real time and refresh. But again, if that takes a lot of computing capacity in transmission, imagine in distribution we have 3 or 4 orders of magnitude higher amount of nodes. And for the power system engineers here in the room, I'm sure there are a few of them, as you know, the computational complexity goes up with the square of the amount of nodes. So when we double the amount of nodes, computational complexity quadruples. Or in other words, if we have 3 to 4 orders of magnitude higher computation amount of nodes, instead of thousands of nodes in transmission, in distribution we have millions or tens of millions, then we are talking that we have 6 to 8 orders of magnitude higher computational complexity. And the last challenge is in transmission. I always say the traditional SCADA systems or ADMS in mid-voltage, these are machines that transform gold into gold. They take gold and instrumentation. I mean, if you see the instrumentation standards in transmission, you have these high-resolution meters, often 2 of them. If one breaks, we have another one. They cost 20,000 euro per unit. Imagine if we instrumented that to that standard in low voltage, right? It will cost hundreds of billions. So if we want to get these superpowers in distribution at a reasonable cost, we need to do it with what is already there. And what is already there is smart meters, for example, right? They were designed for billing, not for real-time instrumentation. They are not high resolution. There is latency. On topology, normally in transmission, you have these topology teams that curate manually every single change on the topology, but for a few thousands of nodes. But imagine the amount of people you will need to do if you want to curate your GIS. And so normally you have a lot of errors. All DSOs we work with, over 30 now, we find a lot of errors because field operation teams don't always update the GIS correctly, and over time you accumulate lots of errors. So, you know, how to provide these superpowers when you have immensely more amount of nodes and complexity and an instrumentation level that is not comparable with the ones you see in transmission, right? And the answer to that is AI. And that's why this problem has not been resolved. And we don't believe we can do legacy plus systems. From ADMS needs very good instrumentation to work, and then it provides good output. But if you want to work with smart meters that sometimes break, sometimes they send wrong measurements, there are errors in topology, the only tool that can do this now very well is AI. So at least you guys have an immense challenge, but you also have the tools that Edison didn't have 100 years ago, right, to address this immense complexity. So we jump into this, and by the way, this picture here is from my app in Tiber. That's a flex tailer, right? So my point is a revolution in flex is already going on in retail. Tiber has taken 20% of the market in retail in the Nordics from traditional retailers. I'm one of the customers, and there you can see my house and my heat pump, and you can see how incredibly cold it is in Stockholm this morning. It's minus 9.5 degrees. And I have my heat pump on, spot price optimization. That's the central screen, right? So Tiber push the heat pump when the spot price is cheaper and cut it when it's more expensive, and that saves a lot of money. So a lot of things are going on, outside of the distribution or adjacent to distribution on a flex revolution. I think we have some people here from Smart N as well. They can tell you a lot more things, right? So part of the revolution is already going. Here is, I want to present the onion, what I call the onion. And I will disclose distribution, right? But I start on transmission. So if you think this as an onion, the core of the onion is the yellow, the center of the onion is the core infrastructure, and then you have different layers, and the last layer you have the customer. And so typically you have the core infrastructure, then you have a first layer of software or intelligence, typically the SCADA systems, right, in transmission. Then the next layer is a layer of markets with wholesale markets and ancillary service markets and frequency markets, which in a sense is flexibility markets. There is nothing else than flexibility markets. On the other side of the market, you have the supply of flexibility that used to be hydro and gas peakers. Now they come the new kids on the block, the flex tailer like Tiber and Octopus, or battery operators or BESS operators like Ingrid or Flower, aggregators like eNode or GridX or Uplight. but they are operating towards two signals. 99% of the monetization is still towards a spot price or ancillary service markets. Then comes the next chapter in grid tech revolution, in distribution, that companies like Nodes or Piccolo, and I'm sure you know them, right? They say, we should have flexibility markets local for DSOs. And the challenge, and we have automatic integration into Nodes and Piccolo, but the challenge that we see is that there is little liquidity in these markets. And it's not because of the lack of supply. All these guys here will be extremely interested to monetize here and do revenue stacking. Many of them are especially battery operators. There was an overbuild of batteries, for example, in the Nordics, so frequency prices collapsed, and now many of them are out of the money, very difficult to pay back the investments they made. When the prices were high, you could do payback in 1 year. Now prices are down 80%, so it's a lot more difficult. So they will be really happy to engage here. But I call this the piñata game, right? If the flexibility is the muscle and the stick of the kid. But if you don't know when, where, and why, your bottlenecks are happening in your feeders in low voltage, how can you possibly automate this, right? And send real-time command signals. And so that's what we, why we started FlexiGrid. And we don't think we can legacy plus ourselves to the intelligence stack that is needed to do this in real time in distribution with all this complexity. It's got to be built from scratch. And the design of FlexiGrid, the real genius behind the technology is Pablo Arbolella, who is one of the best electrical engineers in the world, in the sense that he got literally Outstanding Electrical Engineer of the Year from IEEE in December 2022 for the design of the FlexiGrid technology, and he's my co-founder. He's so humble, he'll never tell you, but I'm a lot less humble, so I love to brag on his behalf. And here is the flexibility iceberg, right? So up to now, 99% of the monetization is done with energy arbitrage or frequency control. But we could do incredible things with this outer ecosystem on the distribution grid. We've been able to do, of course, tackle overloads in transformers, but we've been able to manage overvoltages, undervoltages at feeder level with flexibility. We've been able to deal with phase unbalance and rebalance phases because also distribution is immensely more complex in that it's three-phase plus neutral and balance, where transmission runs perfectly balanced. And so I'm going to show 3 or 4 examples which I believe all but one are E.DSO members. This is the first model we built with one of the largest DSOs in Spain. This is low voltage, it's street level. And the first thing you can see is how immensely complex. The moment you start to have rooftop solar, batteries, EVs, this is a heat map for voltages. You have over voltage in this feeder and simultaneously under voltage in the next one. Why? Because here there is a sports arena that installed a huge solar roof, and here there was a public parking that installed fast charging. How do you solve this with time of use tariff? What price do you put to this? And there are so many DSOs now struggling, right? In Spain now at 4 o'clock we have curtailment and EVs and heat pumps and air cons that could be, consuming this curtailed power that we are throwing to the garbage, but they are not doing it because according to the tariff that's peak. And, if you fix this, you screw up the other thing. It's impossible to get it right with time of use tariffs. You will have to do nodal pricing per street, which we are doing with Vattenfall in the island of Gotland. But it's quite complex. So you translate basically these colors into real-time prices, like a spot price per street for the grid. It's possible. But you can see here the superpowers of being able to compute a state and refresh it on real time, or every time we can refresh telemetry, right? Every 5 minutes, every 15 minutes, we read telemetry and we refresh the state of the grid like a TSO. Here we are modeling what happens if we activate flexibility. You see most of the bottlenecks were gone. There is a stubborn bottleneck there in the center that will need an upgrade. You can see, by the way, there the difference in phase and balance. The 3 colors there are the 3 phases, and you can see there is quite a lot of difference in load between the 3. So there could be some rebalancing. Now we go to the other side of the world. This is the one that is not E.DSO member because it's the Auckland operator in New Zealand. And they couldn't connect, sorry, I need to come back. oops, sorry. Yeah, they couldn't connect more EVs, and they got a lot of political pressure. Oh my God. Can you activate the video from there, perhaps, or? Yeah. Is it running now, the video? Yeah, now. Well, okay. Third time lucky. No. Well, I was about to show you, but the real time, you cannot activate the video, right, from there. There we go. So we compute the state and under voltages on real time, and when it gets bad, we reschedule the charging of the EVs. Voluntary, but we got 93% voluntary adoption for users because they rather connect on Flex than wait 1 or 2 years for a reinforcement on the substation. We were able to double penetration of EVs and at the same time control overloads in transformers and under voltages in feeders very well, big success. The last example I'm going to give, well, I have a quick other one. This is with local flexibility markets at substation level. This is in the Nordics, okay, with one E.DSO member and with one of the local flexibility markets. So what you can see is that I'm going to stop here. No, I cannot stop the video from here. Sorry, guys. I promise you. I get nervous now. Okay. So you will see, we are going to assume in the substation, you're going to see that in the morning there's no problem, but later in the evening we can forecast a big congestion, a big overload. In yellow, the yellow bars below is the flexibility registered in nodes in the local flexibility market in this substation. The dotted yellow line is what happens if we activate all the flexibility. You see there is enough to solve it. And the dotted blue line is the optimal activation of flexibility. We just need to activate enough. And if the flexibility below is available at different price, we take typically the cheapest, or the cheapest combined with social fairness factors. And well, I will not come back to the video, but the machine automatically creates the transactions, the call-offs of flexibility on the Piccolo platform or on the Nodes platform. At that point, we are creating that synapses, these automated synapses that you see already in transmission, right? Frequency markets, they are not traders talking to each other. They're machines talking to machines, right? It's fully automated for thousands of nodes. If we want to create this with millions of nodes or tens of millions, it's got to be automated as well, all these transactions. And at that point, you will see an explosion. I mean, in all the grids where we have deployed this capability, you see an explosion of liquidity in the nodes market or on the Piccolo market. And the last one is this E.DSO coordination. Ever since the Spanish blackout, by the way, Pablo is also in the independent expert committee looking at this. But we talk about transmission and distribution as separated things. One thing we see is that once we go for flex connections, that will be the new standard with this grids package. When we do things in distribution, we release hosting capacity at transmission. So you can see what's going on. I mean, it's all interdependent. And you know, we all know it's wired, but sometimes we talk about capacity planning in transmission, independent of capacity planning and flexing in distribution or in transmission. And you see up there in the corner is the high voltage substation where maybe Google wants to get a connection for a data center, and apparently there is not enough headroom there. But if we put in distribution a flex program, it will release hosting capacity, and we have seen it in a number of nodes that is enough to create enough headroom for the Google data center to be feasible. And I think it's in everybody's interest it's not reinforcement or flex. I don't think we have a choice. We are competing against China. China deploys transmission lines in 1 year, and here it takes 10 years. So we probably need to do both. Cut the timeline of 10 years to 5 years, or as little as possible, and at the same time, blend it with these kind of tools so that we can speed up connections on flex, and only then we will come closer to the Chinese speed or The second fastest is the Texas speed. There they are pretty fast also deploying infrastructure. And I think Europe, we have no choice but to blend these two to go at the speed of light with electrification. Otherwise, we're going to lose these investments and jobs and demand forever. It'll go somewhere else, not in Europe. Thank you very much.
Thank you so much to FlexiGrid, our sponsor, and thanks also to Sedalis Tikels and to Petrus for joining in the presentation today. And so now I'd like to kick off our second panel. I'd like to call Anne van der Molen, who is a strategic advisor at our member Stedin and also vice chair of our technology and knowledge sharing committee. So Anne, please come forward.
Good morning, friends. I have the honor to introduce you and set the scene for electrification. Do that in around 6 minutes. Being a technology knowledge sharing guy, of course, you will get a technology and knowledge sharing story. And let me start with this. Maybe you've seen this when you entered the room here in the lobby. There's a big display showing a technology radar. It is an activity that we have ongoing for a while now, and it shows basically the kind of technologies that we will get into the power system. So if you speak about an electrification of the system, you could say from technology perspective, this is what you need to do, apart from the things that we are already doing today, because we've seen a lot of solutions, activities and things ongoing already, but this is what is coming already. You could argue, is this 8? Maybe not, but that's the whole idea, to start a discussion of what is coming, when is it coming, how big is it, how disruptive is it changing? It's important to understand that, we figured. What you see, for instance, is that it's diverse. It's digital technology, it's energy systems technology, it's storage, it's solar. It's a lot of different things that are coming. So electrification is a multidisciplinary thing, basically. You could also say, well, it's new technologies, and it's not a one-off thing. You're not for sure that things will happen in 3 years from now. They might go faster or not come at all. So you need to monitor that. Actually, this picture was drawn from the daily practice and of the E.DSO members, which is around 30. So this is not what is planning, no, this is actually the feedback and the things that are actually ongoing, the requests that are happening across Europe. And it's not only the feedback from E.DSO members, it's all feedback from basically everyone sitting here. It's policy makers, it's the heating industry, it's transportation, it's a lot of things. And yes, we try to summarize it a bit, because if you would have the complete picture, it would be, well, 3, 4, 5 times as many technologies, basically. And that's understandable, because behind the technologies there is interests. There's economic factors. So there's opportunities, companies wanting to invest and wanting to scale up technology. We've seen this before today, but this is a really part of electrification. And threats, obviously, also. So the technology landscape is changing. Talking about the E.DSO of the future and the architect, we need to understand that the system is, of course, not only changing in scale, meaning grid capacity, it's also changing in capabilities. Things we need to do differently, or new things that we need to do. So if you're an architect and you want to shape the system of the future, you need to also prepare for new capabilities. And not only prepare, but already have prepared them, because things are happening fast. And of course, it's both policy, yes, it is policy, it is also business opportunities, but also, more on the softer skills, about sharing knowledge, sharing successes, and doing things. Because one thing we know, we do not know exactly when, how, and where it will happen. That might change, but we need to also be ready for that change. We need to be adaptive, and we need to be able to change faster, different, or at least continuous. And we need to do this together. It's not somebody needs to do this, no, we need to do this together. So that brings me a bit towards the panel later on. The question is, how do you organize this? How do you drive this change? Because that's what we need to do. That's what has been said. The system is changing. We need to drive change. We need to steer change. So how do you do this? You could say, well, I set ambitions, and I prioritize. I set ambitions. I make sure that the technology I discover is impacted, assessed, or it is scaled up fast. Or I focus on active participation, because everybody should be able to take part, not only use the technology, but also introduce the technology, and in the end, have a profitable business case. Another angle could be to have focus areas, like there's a few ones I listed here. There might be other ones, but at least it's more a thematic approach. And that brings me to my question to the panel. Talking about electrification, knowing that we need to are changing in a rapid pace, or in a pace that we might not know, what would you like to have in your toolbox? What should be in there? Having said that, Mark, I would like to hand over to you and to the panel. Thank you, everybody.
Annie, thank you very much. Set the stage beautifully. I'm going to start out with a thank you first for Paula and the E.DSO team for including EPRI in the planning and execution of this conference. It's a great conference. We were involved last year. It's the best gathering of distribution experts that we have in Europe, and EPRI's really proud to be a part of it. And also mention that we have our own European Workshop Week that's in Prague at the end of March. E.DSO is a co-sponsor of the distribution session there, so we have stuff at our stand about that conference, so come on out there. And with that, I want to introduce our panel here to try to answer Anne's challenge of what needs to be in our toolbox, and we'll come to that as our wrap-up question as well to see how we did in answering that. But we have some really good perspectives on this challenge of electrification, which is, along with renewables, is really the key to our decarbonization goals. Electrification of other energy sectors, transport and heat primarily, and building a grid infrastructure and management system that can actually supply that electrification. So I'll ask the panelists to come on up. We're going to start out with a short perspective from each panelist. Kai Tullius from the European Commission, DG Transport and Mobility, will give us a perspective from the European Commission. Zaini Varfi from Smarten, former E.DSO, everyone knows her very well. Thank you for joining us. Talk from a technology provider perspective. Then we have Federica Sabati from the European Heating Industry, Secretary General. Talk about where electric heating is going across Europe. We have Josh Eichmann with the Catalonia Institute for Renewable Energy, IREC, Deputy Group Lead for Energy Systems. Give us a research perspective. And finally, Erika Niemi from E.ON Energy Networks in Sweden, and she'll help us with a distribution perspective. Thank you. So we're going to give each panelist a few minutes to provide their perspective on the challenges of meeting this electrification objective from all aspects, from technology aspect, from the E.DSO aspect, from a regulatory aspect, and policy aspect, and then we'll come back with some additional questions. So I'm going to start with Kai and get a perspective from the European Commission on where things are headed to make sure that we can meet these electrification goals. No.
Now better? Now better.
Better.
Okay. Well, thanks a lot, Kai Tullius, DG Move, European Commission. I'm responsible in the unit for sustainable transport for the rollout of publicly accessible recharging infrastructure. And you also set the technical standards for recharging points, be it publicly accessible or private ones. So from my side, you rather get a little bit of a demand perspective here. Because I think you've seen that in all our communications from the Commission. We actually see a huge increase in demand for electricity. Part of it will come from the transport sector. At the EU, we have a climate law with the aim to actually be climate neutral by 2050. Translating that into the transport sector and the road transport sector in particular, it means that basically by 2050, all vehicles on our roads have to be zero emission, with a vast majority of them likely to be electric. I haven't seen any recent studies, but older studies suggested that would lead to an increase of around 20% of the total electricity demand. But of course, that's only the road sector. We also have electrification of maritime operations on onshore power supply. We have electrification in airport operations. We have hydrogen production from electricity. So there's a lot of extra demand coming in. And we are not even talking now about the heating and cooling sector and all the other sectors that need to electrify. Cut a long story short, it's a huge challenge for the electricity grid, not only from transport, but from all sectors. I think there are two ways that grids have to be prepared for that. First of all, it's investment into copper to actually connect the new demand. We will see huge demands, especially when it comes to the truck electrification and bus electrification. Single recharging pools along highways will have a demand for at least power of 10 megawatt. We will see the same even in bus depots and truck depots in cities. So there's going to be a massive demand for power that cannot be solved by flexibility alone. But flexibility will have to play an enormously role also in managing the electricity supply to the fleet, so to make it efficient, to actually ensure that it can absorb the renewable electricity being produced. So here, aspects like smart charging and vehicle-to-grid will be very important. With a little side mark, sometimes in the discussions, I have the impression that some sectors believe the golden bullet for flexibility is the mobility sector, and I honestly don't believe that. I think it is one very, very important sector to actually contribute to the flexibility. It will not be alone, and I hope that will be confirmed when we talk about heating and cooling here. So what do we do concretely on the mobility side to actually make it happen? Because basically we need to have two things in place for flexibility to happen, or maybe three really. I mean, we have to have the grids ready. I think this is exactly what E.DSO stands for, smart grids, so that actually can react to demand changes. You have to have the economic offers to the vehicle owners, to the transport operators, to actually provide flexibility, because transport operators will only provide flexibility if it actually reduces their fuel costs, without actually leading to admin burden, and certainly without affecting their operation. Let's not forget, trucks and buses are assets. They need to operate. So flexibility can never, ever lead to the fact that a bus cannot leave the bus depot in the morning because it provides flexibility. It has to be full. So there are constraints here that needs to be met. So it's all about a reasonable offer for the operators. And what needs to be in place is the technology, is the interoperability of the system. And Mark has been here, and we are working here with Mark von Stippold on the whole data exchange requirements. So on the recharging side, we mandate recharging, smart recharging capabilities. We mandate standard ISO 15118-20 on all recharging points, be it public or private. That is actually the very foundation for any sort of data exchange required for smart and bidirectional charging. And I think on the energy side, we are looking here at the demand response network code to actually also provide here for operational rules for demand response. So this is where we stand, this is where we are going.
Great, great. Why don't you just hand that mic to, Zaini has a mic already, that's great. We're going to go to Zaini Varfi and get a little technology perspective on what technology providers see as the challenges as they look to connect to the grid and have to deal with different standards for interoperability and data exchanges, and where do you see the challenges?
All right, thank you for having me. Actually, I like to be here also because this event is very close to my heart, as you know. Now, in terms of what Arne left us as a question and connecting with technology providers, because SmartN presents the flexible demand management industry, which is from the demand side, exactly connecting well also with the Commission, what demand represents in all the story. The industry insights that we have gathered so far shows that from technology point of view, the flexibility is there. So electric vehicles, heat pumps, smart buildings are providing that flexibility. But the downside of it is that there is no activation of it. And in addition to the complexity, I think I am not the first one to say that implementation is not making things easier. So this discourse that I'm telling you today, it's since 2019. We have provisions that say demand flexibility is important, of course, not resolving every issue, but has to count as an important component in the electrification, because then you will reduce actually the massive investment that you need. You defer this investment that it costs a lot to DSOs, but also it makes the system and grid stress just reduce it. And it's quite striking because it looks like an energy we have within us, but we cannot use it properly. And market design is stagnating, we don't have. On top of that, there is this compensation side. So if you don't have markets, and FlexiGrid explain it a little bit, you have local flexibility market not being procured, or at best in the pilot stage. And we said pilot is good, but once you test, you have to be permanent solution or to find a solution that could stand in the years. And then we are seeing that basically if we have to use an analogy, it's like a football game that we see the power planes playing the game, and the flexibility has been in the bench for, I don't know, 20 years right now. So let's say from legislative point of view, we have been recognized as a full component for electrification and decarbonization, but how you will build the business, they don't see activation, they don't see remuneration from the markets, and when there is a market, for instance, the balancing market, when the flexibility aggregators can intervene or buy, there are pre-qualification which makes it very difficult. And I will end my contribution in saying that we have two components which we need to think very seriously. It's like by 2030 we need, and the flexibility will increase by 5 times. And at the same time, and the same pace, by 2030 we need, or the demand on electrification will increase at least from the prediction to 40%. So how you will adjust that without taking into account what the technology is ready to provide today? So I will leave it here. I'm happy to connect.
Beautiful, thank you. And we're going to go to Federica next to talk about, we heard the comment that it's not all about electric mobility. That's not the answer to all our flexibility needs. Heating is part of that issue, thermal storage. And where do you see heating going?
Yes, does this work? Yes. Yeah, I was just going to start with, do you want the good news or do you want the bad news first? Which one comes? I will start with the good news. So first of all, as European heating industry, we represent the manufacturers of heating systems. Heat pumps is obviously the child that is the most promising. And the good news is that, electrification of heating is much more than it is today, is going to happen. And so you will all have a job still from here until 2050 for sure, trying to connect all those heat pumps and make the grid work. Capacity, also production capacity, particularly in Europe, is available. Industry has invested a lot in heat pumps and in all of those features that make heat pumps able to connect and talk with the grid, talk inside the house with other appliances, so that that famous flexibility that perhaps other sectors cannot give can at least partially be given, bearing in mind that obviously heat pumps are made for heating houses and not as a primary function to talk to the grid. But those features are there. So I think this is all good news. Production capacity can also ramp up very easily in Europe. The bad news at the moment is that actually the market is not moving as fast as we as industry would like it to be, but also as the targets that the European Union has set for itself are asking. So just to give you a couple of numbers, the best year was where we first sort of opened our eyes, okay, it's happening. In 2021, we had about 1 million hydronic heat pumps sold in Europe. The year after, 1.5. And then 2023 started the descent with 1.4. Year after, 2024, bad year, 2024 was about less than 1 million. This year is just finished. We are looking still at the figures, but we are going up a little bit again to 1 million heat pumps. We are talking about, however, about 106 million heating appliances in Europe. At such a rate, we are not moving so fast as we would like. And just to mention one target that was mentioned earlier in one of the interventions, Repower EU has set a target of 10 million heat pumps installed in 2027 in Europe and 30 million by 2030. That means that we would have had to install at least 2 million a year since 2023, let's say, and we are less than 1 million. So just to give a perspective of what is not yet a revolution, but hopefully we hope it to be an evolution. And there's a couple of reasons, main reasons for this not happening. The first one at the moment is the price of electricity. Electricity costs too much in most of Europe, particularly when compared to gas. So there is basically no business case for a consumer, me and you, to invest in a heat pump and replace a boiler, because actually our energy bills would be higher afterwards. Second roadblock is that still the installation costs are high, and signals, incentives for these technologies are going up and down across Europe. And then looking at an audience of electricity grids, obviously the grid is still, let's say, how do I put it nicely, has potential for development, let's put it this way. There's other reasons. The installers network is what our infrastructure is lacking at the moment, or there are shortages. Just, I think, as the infrastructure in the mobility sector is, the charging station and so on. I think for us, the charging stations infrastructure would be the installers network and the electricity grid, and this still needs work on. I think we go on in the next questions about how we do it and how we see it. Just maybe to finish saying there's opportunities, there's also challenges, and one of the big challenges is to really work together. I know it's one of those sentences that you hear all the time, but I think it is definitely the time to work together on the value chain from production to transmission, distribution, and consumers, or let's say beyond the meter people like us. And I would just like to offer that kind of cooperation, starting with numbers. We have been collecting sales figures of all heating appliances in Europe for 20 years, and that gives an interesting picture of the evolution of this market and the future evolution of the market as we move towards electrification.
Great stuff. Thank you. We're going to go to you, Josh, and talk about the role of innovation and R&D in meeting some of these requirements. Anna, talk to us about what needs to be in our toolbox. You're involved in the Flow project. What do you see? And we heard from Luis earlier today about the fact that really we got to get past pilots. We're killing ourselves with pilots. We got to get to the stage of taking these innovations and making them just our normal practice. So how does it look from an R&D perspective?
Right. Yeah. So I think throughout today we've heard a lot of discussion about different flexibility opportunities and markets. And with respect to the Flow project, I'd like to focus my remarks today mostly on e-mobility. So we've had some comments, and I'll try to build on those so we don't get too repetitive. And I think many people are already aware that these loads can be a challenge. We saw in the FlexiGrid demonstration in Australia that it can be a challenge there, but it also represents an opportunity when you can flexibly manage it. So again, I mentioned I'm representing the Flow project, EU-funded project, focusing on valorizing EV flexibility. And in particular, we're doing this through several different methods, looking at markets and different incentives. So wanted to at least introduce some of those ideas briefly. I think we've all heard them through the discussions today with local flex markets and flexible connection agreements. So we have 3 major demos. And as part of that, we're looking at managing some services with the TSO, so using EV flexibility to manage TSO services. But I'll focus today more on the local flexibility markets. We're demonstrating those in Menorca, where you can actually, through an aggregator, provide flexibility to a DSO through a bidded program. And then also in Rome, we have a program working on the flexible connection agreements, and Copenhagen as well. So I think it's many of those things that we've talked about. We say we want to go this direction, but I think there's still a lot of uncertainty on how it should work in each country. What should these markets look like? What should the products look like? So yeah, I would say that's kind of where we are, and then I wanted to contribute also that we're part of a larger cluster of projects. So there's Flow and Scale and EV for EU and a number of others that are part of this V2X cluster. So if you find some of this content interesting, there's other markets and other examples that have been that other projects are exploring. So maybe more to the question of where are we, where do we go from here, what's next, and how do we see it? So I think from our perspective in this project, we have had many of the technical solutions have been solved as far as implementing these, but I think again it's really we have a few of these pilots and we need to scale up to these larger volumes. So I think some of the steps were actually identified in a recent workshop that we had as part of the project. It was also supported by E.DSO, and the video's available online if you're interested. A little shameless advertising. But I think it's really related to on that market side, formalizing the structure for the flexibility and instruments and the mechanisms that the EVs can use to participate in that. Again, many small assets, and it has a lot of similarities with other assets, but there might be some unique aspects there. So that's one, harmonization of some of the DSO markets, and which would require communication between those. We have some discussions that say a market in one country doesn't mean I can participate in another country, so I need another tool for another country, another service deployed in another country. So while we have these technical solutions in one country, in order to make them replicable, I think that's one of the keys. And then finally, I think also employing sandboxes where it's appropriate. There was a comment this morning about pilotitis, I think is what the phrase was. So I recognize that. In some cases, I think having some of these sandboxes is a key first step where we haven't been able to fully demonstrate some of these technologies, and that can be a nice first step. And then, of course, moving into this more deployment at scale to be able to demonstrate EV flexibility. So I'll stop remarks there. Thanks.
Great. Yeah, the more we can standardize, the better. Standard services, everyone benefits. All right, we're going to take it to Erica. When I was VP of our T&D research at EPRI, I told our distribution advisors, you really are the center of the universe. Distribution, everything goes through the distribution company. And it's a huge challenge that we have in making it all work. You have to be the interface to the TSO for flexibility. We want to take advantage of flexibility at the distribution level, and yet we need to connect all this new electrification. How are we going to do it, Erica?
Wow, the weight on my shoulders. So hi, everyone. Thank you so much for inviting me. I'm Erika Niemi. I work at E.ON Energy Networks, the Swedish branch. Just so you get an image of the size, we have about 1.5 million customers in Sweden, the Swedish part of E.ON. networks. I'd like to start with the energy transition. Many of you have done that, but we can really see it happening, and from our end, it's interesting to see the Swedish energy transition is about extremely large new projects, like decarbonization of steel. We're talking 1,000 megawatts to 1,500 megawatts, all the way to transport and heating, which is a totally different challenge, many but small. So strengthening the grid is crucial. Also, maybe a little bit different is that we have actually seen that the average electricity price has somewhat decreased. And I'm talking average here because I know that now the prices are quite high. Volatility has also increased, of course. So, but generally speaking, on average, electricity price decrease. However, the price of grid has increased and will increase due to all the investments that need to be taken. Only us at E.ON Sweden, we invest about 600 million per year during a 4-year period, and this is completely necessary. The grids are old, as many of you have already said, and with all the new connection and strengthening of the grid, this is truly important and necessary. But we need to be meticulous where to invest and where to use other methods. And there are methods in the toolbox. There are other tools in the toolbox. And I'm happy to say, because we're talking so much about pilots, that we have 11 local flexibility markets, and none of them are pilots. so I'm happy to say that. And I think the important thing is what tool to use for which congestion problem. Because if you look at this 1,000 megawatt project, I think flexibility will have a tough time to solve that problem. However, when it comes to transport and heating, that's an easier thing, especially with, for example, risk of overload in transformers. All of our 11 flexibility market address the problem of potential overload in transformers. So I'd like to address also another issue, and it's particularly on transport and heating, and that is that sometimes I reflect on what we've heard today, that we just create the market and then everything is solved. But that's not really true, is it? Because what we need is sort of an ecosystem of actors changing their behaviors into moving towards more flexible behaviors. So what we need in order to unlock the potential, specifically I think of small scale, heating, transport, is the aggregators. And Alberto Mendes already talked about aggregator role. It is extremely important for the local flexibility markets to function and to be and to reach liquidity. And to be quite honest, it's not easy to expand businesses all over Europe if you are an aggregator, because the rule of the game is different in each country. The way that the clean energy package has been introduced in all European countries are quite different. Different from the Nordics and Germany, different again in France, in Spain, and so on. So if you are an aggregator and you want to unlock the potential and gather all the small-scale potential, which is huge, I really agree on that, but then we are, well, you people here need to realize that in order for the business model to work, we need to align. And it's about different things. It's about interoperability. It's about the business model of flexibility. It's about the prerequisites for flexibility providers. It's about the smart meter rollouts and so forth. So it's about a lot of things on interoperability. It's also about the regulators. I'll come back to that a little bit later. So from the DSO's perspective, I'd like to broaden how we talk about flexibility as not technical, primarily, and it's not about just creating the possibility and working in a different way so that as a DSO. It's about creating the business opportunities for the whole ecosystem of flexibility. Thank you.
Great. I love that. The value proposition is really the key for all the stakeholders. I'm going to come back to Kai with a question, and I'm going to try to open it up for 1 or 2 questions from the audience after we do one round of questions here. So hopefully we have time for that. But from a DG Move perspective, Kai, and all this talk about flexibility, is there anything in the transport legislation that will come out that can help us push the flexibility angle for these assets as they're deployed, high-speed charging stations, flexibility maybe with additional energy storage? Is there anything that can happen at the legislative side to make sure that we add these, that go through this electrification process and make flexibility part of the equation?
I think you wouldn't expect too much from our side in the upcoming legislative proposals. What we are doing on the infrastructure and transport and mobility side is basically interoperability. Interoperability, a little bit different from what Erika described, but basically it is about the data exchange between the different actors, between the recharging point and the vehicle, and finally towards the electricity markets. So here we are actually doing work. We are mandating these sorts of communication standards through delegated legislation, so that on the technical side, it is actually possible for the transport operators, for the users, to participate in the flexibility markets once they are actually established and once the offers are being made to actually the end user, the car owner or the transport operator. And I think that is basically really here the key that we need. I mean, Erika mentioned the role of aggregators here. That's a little bit beyond what we see. That's the organization of the electricity market. But I think what is really crucial is that there are simple offers being made by the electricity markets with or without aggregators. I mean, I think there are companies, especially in the UK, who actually offer exactly that. Guaranteeing the operators the charging of the vehicle in the specified times, but then giving this sort of companies freedom to do with the battery whatever they want, unless, but that they actually promise, well, we deliver what you specify you need in your vehicles. We deliver that, and we deliver that at a cheaper price than your regular electricity contract. And I think this is exactly where we need to go. I think this is what I think the transport sector is waiting for, and I think what we need to do really here on the transport side is, if these offers are in the market, the system as such, and it's a damned complicated system with loads of data exchange requirements between the different actors involved, that actually works in the interest then of the overall system.
Great. Focus on interoperability and make sure the value streams are there using that interoperability. So Zany, what do you see in the way of, let's say, business models that are actually being implemented to create that value stream all the way down to the customer level, taking advantage of these technologies?
Yeah, no, totally. Actually, when you mentioned the aggregator business model, it's not good, but it's terrible. Because it depends on the markets that are open, and as you said, it's not just a market point of view, but remuneration that you get, and then sometimes you need as an aggregator to represent really massive industrial sites in order to compete or to enter into the market with the necessary load. Otherwise, you are not qualifiable to enter into the market at all. So that is what the independent aggregators, just to make it the complexity even more, it's a new terminology that hasn't been recognized in some member states. So that is also the challenge, how you make business in Europe nowadays. And particularly France has been quite a good example in that regard. TSO proved to be a little bit more open-minded in balancing markets and then having remuneration also in the capacity mechanism for aggregators. So it's a remuneration, a double benefit for them. But when we see in the market monitor what's going on, where demand-side flexibility kicks in, what other markets are open, how can you as a business flourish, it's a bit more black, I would say, than a good perspective. Now, of course, something to link with interoperability, it's very impressive the work that the Commission now has as an individual about a business case of flexibility on a data space sector. European data space is something that has been mandated to all of us, particularly to the Commission, and is trying to figure it out how this will work. So basically the connection would be to have aggregator communicating with the customers and the aggregator then communicating with the TSOs and TSOs, and to have this channel of communication and free exchange of data. This is ongoing. There are 3 business cases being built up on smart bi-directional charging, and then you have the buildings, smart buildings, and flexibility. It's not finished, but of course what's happening is a list of data that you have to communicate that stemming mainly from the system operators when they see where they need the data for what connection with the aggregators and how to make that happen. But in terms of further to this initiative, I would say what we are really looking as from Smart End point of view, and you would imagine also the flexibility having 50 nuances of interpretation, so it doesn't make it easy. We are working and we are waiting for the network code on demand response. This is the year of waiting room because by the end of 2026 normally things should be settled up. And why I'm saying that it's important because it will define or kind of standardize the conception of flexibility. Then it's about pre-qualification conditions, which are very different from one market to another, and that adds complexity. And most importantly is also to activate finally this flexibility that we have without overestimating that we will resolve all the issues that we have, particularly in the congestion side. And I would leave it with that. I would say these are the most important developments.
Yeah. Maybe we would go with that same question basically for Federica in terms of the technical and regulatory challenges to get the flexibility out of the heating sector. Where do you see those challenges? And even though the deployment is not going as fast as we like, it's still an increasing demand that we have to deal with at the DSO level, and flexibility in that demand, demand response would be important to see regulatory and technical challenges in achieving that.
Yeah, so I mean, in terms of also flexibility in general that the technology can bring, we are seeing quite a success in the market of hybrid heat pumps that gives inherently a flexibility because a hybrid heat pump is basically a heat pump together with a boiler. Tendentially it would be a gas boiler just because there's so many more connected in Europe, and that allows the shifting, automatic shifting of the load depending on actually on the outside temperature and or also on the price signals that can give. And this is therefore something that is already in the field and being deployed more and alleviates more. There's been a pilot study, well, it's not a pilot study now, I think pilot study, this is a bad word here, but there's been a field study, that's a word, in the Netherlands a couple of years ago about this and looking at how much in terms of consumption, energy consumption you would save if you installed a hybrid system in a number of houses. I think they took something like 150 houses, unrenovated, without any new refurbishment put in. They just added or replaced the boiler with a hybrid, or just added a heat pump. And across the board, this was it was shown that you can cut energy consumption by 75% just by replacing. So hybrid is something that is giving a lot of of flexibility, and it's something that is available now for, let's say, ripening, using this flexibility in general for heat pumps. Well, we need, we don't need a lot of new regulations, actually. So it was mentioned already before, I don't know if it was Danny who mentioned it, the electricity market design needs to be, has been adopted at the European level, that needs to be implemented. And that there are two things that are missing for us. One is smart meters. I hear it a lot today. Smart meters rollout, it's by far not sufficient so that, the technology like heat pumps can talk with the grid. So we may have all sorts of features, but if we cannot physically talk, then with the grid, this is useless. And the second thing is let's say, flexible dynamic tariffs, because in the end, the demand pattern of consumers like me and everybody else here depends on certain incentives. So if we have an incentive in using, in warming up our house a bit before or after, because that rewards us also in terms of what we pay, then that would be an incentive that will make us do that. If we don't have any reward on that, this is also something that is not happening. So I saw Octopus. Octopus has been as an example, I think, that are here in Brussels since, 5 years? And where's the next Octopus everywhere in Europe? We need that flexibility because in the end, the demand patterns will be remaining the same. You will still want to heat your house when it's cold. It's demand for heating is seasonal, and also within the cold season, it goes in peaks in the morning and in the evening. I mean, you yourself take showers, I guess, either in the morning and not at 12:30. So, or want to have a warm house when you come home. So those patterns will not change. So the technology can help, but there needs to be a reward for using that technology. One thing which, by the way, is overlooked still is the rate of insulation of homes, because if a heat pump with the thermal, the thermal storage you can store heat before you're using it, so you can activate it before the peak time, then you still, if you have a well-insulated house, the heat will remain. But most houses are unrenovated in Europe. We have a wonderful park of historical houses, but that is something that needs to be moved on, and it's also not moving as fast as necessary. So I think certainly implementation of what is already existing is fundamental. One good sign, I would say, last thing, is that the European Commission has just come out with a proposal for the revision of eco-design and energy labeling for heating systems in the past couple of months. And they have introduced a proposal to add some sort of icon that indicates on the heat pump whether it's smart, so whether it has all those capabilities that we were talking about, talking with the grid, talking with other appliances. So that is something that we are happy about, because that would give a signal to the consumer, oh, maybe my heat pump can also do a few more things. Not that it's a fundamental for a consumer choice. I mean, I wonder how many of you would buy a heat pump because it has a smart icon, or whether, it warms faster and cheaper. But still, it's a sign that it has an added feature that would help let's say, the home system work better.
Great. We're winding down, but Josh, can you give me a comment on how much vehicle to grid adds to the flexibility that we can get out of the kind of the whole electric vehicle picture in terms of flexibility? Yeah.
So maybe I start and I can comment more generally on when you look at these, mobile high capacity batteries, we have the high potential, very high theoretical potential for the available storage. But in practice, we find that it's obviously a lot lower, right? So it depends on where you are. Are you in the region that needs assistance at that moment? Do you have particular needs? Are you driving around for a long distance or something? So I think that can significantly limit it, but at least from our perspective, we see kind of a couple strategies to address that. The first is obviously aggregation. There was mention of this market liquidity challenges. So through aggregation, we're seeing on the Flow project, the partners there, the aggregator there, saw that in one of the markets in Rome, they said, hey, tens of vehicles, there's pretty high variability there. We're not confident in that product. But once you get to hundreds of vehicles, then we see a lot of that is gone. And I think these are the orders that we're going to see in terms of vehicle availability. So I think that addresses it on potentially one side. And then, yeah, moving to a bidirectional environment, I think opens a lot more doors for you. So if you have charged your vehicle up, then that's it for your providing flexibility. If you can't discharge the vehicle, you have no ability to charge anymore, and without the ability to discharge. So I think, yeah, we see that as a really key opportunity. There was mentions of interoperability being one of the challenges, and so yeah, there's several things there, but that's it. So and then maybe one more comment. So yeah, increase in numbers, aggregation, and then also we see this continual rollout of infrastructure as well, headed toward this kind of ubiquitous approaches for charging, not only smart charging, unidirectional charging, but also bidirectional charging.
Thanks. The question I have for you, Erica, is all of these flexibility resources and demand response, how are you integrating those with your planning process? How do you actually make decisions between investments and these flexibility resources?
Yeah, thank you. I'd like to start answering that question with what happens before there's a congestion. Because what we are constantly focusing a lot about is increased grid utilization everywhere in the grid. Just to give you an example of what I'm talking about, using data in order to analyze how much more we can use our overhead lines compared to what we do today. Better data, and data doesn't have to be rocket science in this case. It has to be like really exact asset data, local weather data, and geographical data on the specific lines. And we've created a model combining these three data sources and compared them with the top load that we today allow on our overhead lines, and we can see that we can increase the load on these overhead lines, specifically during wintertime, and wintertime is top load months in Sweden. So before we even have a congestion, we can work with increased grid utilization. But when we do have a congestion, what we do is we look at the problem. What kind of problem is this? Is this a 1,000 megawatt problem, or is this a problem that can be solved with flexibility? Is this a problem that cannot be solved with a market flexibility, but it could be solved with a single non-firm connection agreement? Well, then we choose that. If it can be solved with a market, we will start a market. But the first thing is to increase grid utilization, because that's sort of the starting point.
Great. And I think in order to stay on time, I'm going to kind of leave it there and just, I think we've got the answers to Anne's questions in terms of what we need in the toolbox, in terms of interoperability, in terms of business models, in terms of market structures, the technologies themselves. And I think it's important to recognize the comment that Luis had earlier about it really needs to be automated. We can't expect customers to be changing their settings and responding to flexibility requirements from the grid or the market manually. Everything needs to be automated. And with that, I'm going to encourage you to go see Lawrence Schmidt's display. He'll talk to you later, and the DC Bell box that goes on the house. And from a customer perspective, helps the customer automize everything. It's not advertisement for that, but it's just an illustration that the technologies are there to automate this. And it's a matter of getting them out there and having the standard services and interoperability to take advantage of them. So with that, I want to thank the panel. It was a great discussion. I really appreciate it. And we'll go on from there. Thank you.
Thank you so much to our second panel, and thanks to Mark, and thanks indeed to EPRIA, who's one of our sponsors today. We will have lunch soon, but before lunch we have, I think, a very exciting and entertaining food for thought session on AI as a co-decision maker, how AI redefines leadership. And we have Jasper van Ooyen, Senior Manager for AI and Data at Valcon, who will give engaging in a presentation before your lunch break. Jasper, the floor is yours.
Hello, hello. Yeah. I know it's a bit dangerous to stand in front of a big group and there's lunch on the other side. So please bear with me and I'll take you through this and then we can have lunch together. The energy transition is at a brick wall. Grid complexity, decentralization, electrification, cyber risk, workforce strains. These are the challenges that are growing faster than our capacity to deal with them with traditional leadership. AI is not a luxury. It is a necessity for keeping up. Only your AI-driven leadership can tackle these challenges that outpace human capability. To understand what's changing, let's look about how AI is transforming the industry in 3 horizons: today, tomorrow, and beyond. Today, AI is already helping. Grid operators use it to predict failures. Dispatch teams use it to get smarter recommendations. Leaders have dashboards that turn raw data into valuable insights. Actually, most DSOs are already using AI, even if they don't call it that. There's one DSO now in Germany that uses AI to predict failures 48 hours in advance, reducing outages by 30%. AI today is a quiet partner, assisting, alerting, optimizing. It's saving time and keeping the lights on. As we move forward, we see that this role of AI is slightly changing. It's from an assistant moving towards being a collaborator. Instead of generating reports, AI will ask you questions that you hadn't even considered. One large European utility is now using AI to simulate investment trade-offs, turning multi-day decision-making processes in a couple of minutes of scenario exploration. And it will do that while including the right departments, legal, finance, engineering, creating a level of coordination that humans struggle to match. And beyond that, AI will take even on a greater decision-making responsibility. It will co-lead. Some organizations are already exploring that, but can you imagine this future and how that looks like? Let me take you through a day of a future decision maker reshaped by AI. And we'll do that at, well, a typical day for most of you guys with 3 topics: operations, regulations, and workforce planning. At the start of the day, you enter the office. It's 9 o'clock, and you want to know what's happening. Overnight, the grid has kind of like ran itself. An outage was predicted and rerouted automatically, and your AI operations assistant gives you a 2-minute summary of what's happening. Everything is running, and there's basically no emergencies, just optimization. Don't mind me. Humans are still critical, but instead of doing costly firefighting, they can focus on resilience design. Yeah, there we go. At 12 o'clock, you want to go for lunch, but then at that point, a new regulation drops. Normally, you would have to skip lunch, but in this future, not anymore. Your AI advisor has already read the entire document and has identified 3 changes that are different to your current grid protocols. It even notifies the relevant departments. Compliance is no longer reactive, it's real time. Then at the end of the day, you're looking ahead to your workforce. is your workforce still ready for the future? Your AI model forecasts retirements, emerging skill gaps, and future automation impacts. It recommends who to retrain, who to hire, and where to shift the resources. No more clarity in your, no more guessing in your workforce planning, just clarity. You see that throughout this day and even before that, AI is taking on a different role in decision-making processes. And let me put this in a bit of a historic context. What AI changes. So, in the past, processes might have looked like this. This might have been a couple of decades ago where there was no automation, no digitization, and no standardization, meaning that there's a lot of feedback loops that might not make sense, a lot of waste in the process. Then, over the past 20 years or so, we, as the industry, have worked a lot to make those processes more lean, cut out the waste, make sure we unify the way we do things. This enabled us to take it even one step further and digitize a lot of the processes. We put it in platforms, make sure that we collect data, and with that data, we're able to analyze and optimize even further. Now, over the past 5 years or so, AI came in. And most of the AI that is now used is used in this way, where it's not taking over the entire process, but earlier, as mentioned today, the human in the loop still is the key to make a process run. Now, the next step of AI is a more agentic version of it, where you really transform a process end to end and give AI more autonomy to run by itself. This means that it can be triggered by something else than a human. It can lead the process. It can give tasks to certain other agents and have another agent control those agents. And in that sense, take on a greater decision-making responsibility. But what does this mean for you as a leader? You see that the complexity, the scale, and the size of decisions that are being made by AI fundamentally are different than our previous leadership. This means that leadership must evolve, not just in mindset, but both in structure and rhythm. So we are going to walk through the organization reimagined. And the first thing that you need to take on as a leader is that learn faster than your tools evolve. Your knowledge of today becomes outdated quicker and quicker. Leaders need to build networks even beyond their sectors, absorb new patterns fast, and stay open to rethinking their assumption. The second point is lead humans and AI together. Your future workforce will consist of both humans as well as AI. That means that your job is to make a system where both can excel next to each other. That may mean rethinking roles, workflows, and decision points. And if AI is taking on more operational tasks, it's your job to make sure that people and AI can collaborate, trust each other, and even learn together. The third point is set direction. Don't micromanage. With AI making faster decisions, leaders must spend more time setting intent and boundaries. Clear rules, shared values, and ethical red lines become the tools of alignment. You won't review every choice, but you do define how good looks like and when to escalate. The last point is build organizations that adapt continuously. It's not enough for you to change. You need a whole organization to think differently, being able to experiment, being able to pivot. That means shortening planning cycles, simplifying approval chains, and empowering teams with more autonomy. In an AI-driven world, adaptability becomes your greatest asset. Now, how do you build a competence around AI to actually enable this? The first thing is here that you need to centralize this capability. Centralizing this capability means that you are able to create speed, focus, and create standards that are then being cascaded back into the organization. And there's 5 components that you need to think of when you want to actually get this running. The first one is AI strategy. You need to know where you want to go. This sounds very simple, but you do need to understand how AI will fit your corporate strategy. This means getting it more concrete than just some statements, but really think about how your value chain can benefit this new type of technology. Then you need delivery capability or muscle. Although there are organizations that are very, very modern, have AI, that build AI, in a lot of your organizations, you still need people to really understand how a process works and where in the process AI will benefit. This, as you can hear, it's not only about building the right model, but it's really understanding how a process works and improving it from there. The third point is AI architecture. With AI developing and new technologies popping up, in your organization, a big mushrooms can appear, and you need to make sure that you keep that in control. Also mentioned earlier today, having a manageable technical landscape is extremely important to make sure you're compliant. The fourth point is AI governance. Don't wait for problems to emerge. Define now where AI can be used, who is accountable, and how performance and fairness will be monitored. Clear rules and build trust, and not just mitigate risk. The last point is change management. This one ties it all together. And here it's important to realize that not everyone in your organization needs to become a data scientist. In fact, people need to know what AI is, what it isn't, and how they can use it responsibly. Start by building literacy on leadership level, and then create target training programs to cascade it down back into the organization. Use hand-on experimentation for people to build trust and confidence, because in the end, people don't adopt what they don't understand. Now, how to get started. And I have to laugh here a bit because the word pilot is named a lot, but actually a pilot is an important first step. If you don't take that step, you're never going to build the confidence to industrialize it and go to production. So get started, even if AI feels like the new gold. With those target experiments, you're building a proof that it actually has value in your organization. And this is the type of stage where a lot of companies are now. It's the type of use cases that are being presented on these type of stages. But the trick is actually to take it one step further and to scale success. To take those use cases out of certain departments and being able to exploit that to the rest of the organization. The fourth stage is stabilize. At this point, you have been able to make multiple value chains work with AI. And you don't need a central competence anymore to steer the transformation. It's part of your organization's DNA, and at this point you can decentralize this back into your organization. As mentioned, most organizations are now somewhere between stage 2 and 3. There's a lot of flagship use cases that are successful, but getting the real AI transformation done across all departments is something where AI still, or where organizations still struggle. Now, let me take this back to you. On the stage, I've placed there we go. On this stage, I've placed an empty chair. Now, why did I put this chair here? Jeff Bezos famously kept a chair at every important meeting at Amazon, embodying the customer, who had to be at the heart of every important decision being made. Now, what if this chair is filled with someone else or something else, an AI system, and not to replace us, but to join us? Throughout the examples that I've given today, a lot of the decisions that were made or shaped were made by AI. And in that case, this chair becomes a powerful symbol. It represents the growing influence of AI in our leadership room, and hence creates a question for each of us. How will you treat that chair? Will you ignore it, keeping it at arm's length, or will you pull it closer, define its role, and actively shape how it collaborates with your team? I think it's fair to say that the future belongs to those who understand how to bring people and AI together. So the next time you're sitting with your team and in your meeting room or in your leadership room, there is an empty chair, I want to ask yourself, will you lead with AI or will you be led by it? My name is Jasper van Ooyen, and thank you for your attention.
Oh, okay, thank you, Jasper. Great. I just want to remind everyone before we head off to lunch that we will be having our, after lunch, our presentations, and so this is the code for voting for our third Digital Innovation Award. I also would like to remind people to visit the networking area where you can visit these innovation startups as well as the projects and our sponsors. So enjoy the lunch and see you back here in about an hour and a half.